Today we're going to continue on in Unit 5, Graphing Functions. We have already done the absolute value functions. Now for the rest of the chapter we're going to do piecewise functions, step functions, square root functions, and cube root functions. So this is day 3 of Unit 5. And what we're going to do in today's lesson, rather than move on to one of these new functions, we are going to do a little bit of review. So today we'll be talking about how do we solve systems of linear equations. Just to expand on that, so we've already done linear systems, okay? We've done this. Now we're going to add absolute value and exponential functions. So really all we are looking at is the 3 types of functions we have covered this year so far. So we've done linear equations, which of course is a straight line, absolute value, which is kind of a V shape, and exponential functions, which usually look kind of like this, and then they shoot right up. All right? So remember, a system, okay, a system is 2 or more equations. All right? So what we want to do, the solution is going to be where the functions intersect. So our final answer is going to be a coordinate. Okay, and remember x, y. Okay, so the first thing we're going to do is we're going to look at each of these and we're going to decide what they are. So looking at this first one, this is going to be an absolute value. And the second one, that one is going to be a line. All right. So depending on how these look, we are going to get 2 answers, or 2 graphs rather, and wherever they intersect, it's either going to, because it's a V and because it's a straight line, it's either going to be 0, 1, or 2 solutions to this equation. Okay? So the first thing we're going to do is we are going to put these all into our calculator. And let's get this down. Okay. So let's clear everything. So just a reminder of how we get this. So we are going the math button, go over to number, the absolute value of x minus 3, end your parentheses. If you have the other type of calculator, then you can arrow over. Okay. So you're going to hit graph, straight line of course, and there are your coordinates. I'll put those down in a minute. The next thing we're going to do is before we actually I want you to see. So this is the same thing as y is equal to 2x minus 8. All right. So it's just kind of backwards. So again, I'm going to put this one into my calculator. So 2x minus 8. All right. So I always look at the graph first before I actually graph it, because then I know how many answers I'm going to have, how many solutions I'm going to have. So it looks to cross only one time. All right, so the first thing I want you to do always, of course, is to copy down the graph. So what I want you to do is I want you to scroll down until you see where that intersection is. Okay, so I see, all right, so for my y1, so my absolute value, that is going down, 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 and then it turns around. Okay. Then I also notice over here, at 5, when x is 5, both of the functions are the same. That's what we're looking for. Okay. And then it scoops around again. So what I'm going to do is I'm going to copy a bunch of these down. I'm going to do numbers 1 through 5. Okay, so I'm just going to copy down that table. Okay, so I graphed both of these. All right, so again, I just copied the table. All right. Of course that would happen. Okay, so I put both of the graphs in, and all right, so the pinkish purple line, that is our absolute value graph, and then the blue line is our linear equation. So as you can see, our solution is at 5, 2. Okay, so let's circle that. There's that 5, 2. Okay, so again, I used all my points, and I graphed those on our graph. So the next thing I wanted to show you is how we are going to actually get that from our calculator. So I'm going to take you back to the calculator. Okay. So what we're going to do is, I'm just going to show you the graph one more time. Okay. So what you're going to do is you're going to go to second function calc, and we're going to go to intersect. If you think back to when we did our linear functions, I showed you this as well. So the first thing, we're going to go to our first curve, which is right here. Now your calculator automatically does this, okay? You shouldn't have to guess, but if you'd like to get a little bit closer, you can guess, okay? Or you can just press enter, and again it tells you 5, 2 is our function solution to our systems. Okay, so that is an example of an absolute value and a linear equation. All right, so our next type of system is, so see how this right here, we have an exponent of 1, so it looks like there is no exponent, but obviously we know there always is one, whether it's 0, 1, or even x. So for this one, we'll call this y1. Okay. This is a linear equation or function. And the second one, I will call this y2. This is exponential. Remember, whenever you have an x in the exponent, this is exponential. Okay, so we can't quite put this into a table yet. First, I see that this needs to be solved. Okay, so what I see is if I'm going to subtract my 3x. And then I'm going to divide by 2. Okay, so that is what I'm going to put into the calculator. Okay, so now we're going to put these into our calculator. So whenever we do a fraction, remember we always do this, and I'm going to do an x on the outside, minus 1. And my other one is 2 raised to the x. So we'll take a look at our graph. There's our line. And there's our exponential function. So I see again that it's only going to be one intersection point. So go ahead and look at the table. Okay. So now for this one, I got to scroll. Okay, perfect. So see how at -1 we see that our y values are the same. Okay. So I'm going to do from -2 2 to 2. And I'm going to graph both of those, and don't forget to put that onto paper. So again, I simply copied down the table, graph them, see where they intersect, and again, this is really why you guys are going to want to use your calculator for this. Please make sure you are practicing doing this during the video. It's going to be really hard for you to see this from the naked eye on your calculator unless you look at the table. Okay, so once again, let me get rid of this. I'm going to show you just a reminder. I'll probably do this for each of them. Okay, so so that you can see this on your graph. So you're going to do, again, second calc. Scroll down to intersect. First curve, enter, enter, enter. And you'll see -1 and 0.5 is your answer. Okay, again, please make sure you're practicing this on your calculator as we go through. All right, for number 3, we're not going to actually graph them. All we are going to do is write down what they are, and we're going to throw it into our calculator. So first thing I see, this is exponential, and this is linear. Okay, please make sure you ask if you still don't understand how to tell the difference. But again, remember, our exponential functions have an x in the exponent. Our y and our x for a linear are going to be, down below. No exponents, no variables in the exponents, and our y value and our x value should have an exponent of 1. And then our absolute value, of course, that has an absolute value symbol in it. Okay, so what I did here while I was talking was I just substituted, I solved for y, because remember it's a line. So go ahead and put this in for y1 and this in for y2. So let me fit this in the screen. There we go. All right. So again, y equals, all right, so we have a -2 raised to the x power, and we have 3x minus 28. So go ahead and graph that. Okay. Okay, so now the big thing about this is we don't see where it intersects. Now I don't need to trace it, so again I'm just going to write down the steps. Okay, so graphing in calc. Alright, so the first thing you're going to do is you're going to hit second trace, and then number 5. This is the intersect. Okay, and then you're going to hit enter, enter, enter. Alright, so let's make sure this works. So I hit the second function button, I hit the trace button to make that calculate. Either hit the number 5 or scroll down, enter. Okay, so I hit enter for the first curve, enter, enter, and there we have our intersection. So this means that my solution is 4, -16. Okay, and we did that all on our calculator. All right, number 4. Okay, so if f of x is 3x, 3 raised to x power, sorry, and g of x is 2x plus 5, at which value of x is f of x less than g of x? So, again, I'm going to put this into my calculator. Okay. All right, so please make sure that you clearly mark which one is your f of x. So I'm going to say y1 and y2. This way I know, so I want f of x, so I want y1 to be less than y2. And I want to know at what x. Okay, so I'm looking at the x value. So go ahead and put that in. So I get 3 raised to x power, and then 2x plus 5. So now you can graph it if you want, but that's not really what's going to help us. What's going to help us is we are going to look at our table. Okay? So now I'm just going to look at the x values, and I'm going to see when is f of x less than g of x. Okay, so when is y1 less than? So if I scroll down to negative, so let's go in order of how they gave it to us. So for -3, that's not right because it's negative. Okay, at 2 we see. So here it is at 2. They are the same. That doesn't work. All right. So no. And we already did -3. I'm hoping you can see the answer, even though I haven't done it yet. So if you look at -1, okay, that's going to be our answer, -1. Okay, so again, I just wanted this one, so I want this to be less than. Okay, so that happens at -1. All right, so we have two functions. We have the absolute value of x minus 3, and then we have 3x plus 3y is equal to 27. So we have a couple of these questions. So again, this is an absolute value. We'll call this y1. This we'll call y2, but we have to solve it. Okay, so let's do that quick. And we want to find the true statement. So we can't really find the true statement until we can look at this linear equation a little bit nicer. Okay. Remember, I told you those earlier chapters are not going away. So here's where we practice. Okay. So I get negative x plus 9. That's going to be my y2. So what I want to know is, first I'm going to look at where they intersect. But, well, really first I would like to put these in my calculator. So go ahead and put those in your calculator. Okay, so remember our absolute value is going to be y1, and our linear equation is going to be y2. So is 3, 0 a solution to the system because it satisfies the equation y equals x minus 3. So the first thing we want to look at, so right off the bat, I'm going to cross off 1 and 2 because they need to satisfy both. Okay, so that one we can reject right away. So as I go down, and we can look at number 4 as well. So what this is saying is that at 3, 0, 9, 0, and 6, 3, that these are all solutions. Well, if I look at my graph, I see, well, there's only one solution. So number 4 can't be right either. Okay? It says that they all satisfy at least one. Okay? So let's just make sure that that's not true. So 3, 0, yes, that does satisfy. That does satisfy the first equation. 6, 3, that is both. So we have that. And so 9, 0. All right. So just to reiterate, so are the solutions of the system, right? That's not true. Okay, so our answer is 6-3, and again, we have that right here. We can see that clearly. Okay, so for your homework, or classwork if you're done, what I would like you to do is questions number, hold on 2 seconds. Questions number 6 through 9. Okay, that's going to be your homework. So for number 6, you can use, what was that one? Use number 4. Okay. For number 7, use number 1. Use number 2. And 9, you can use number 1.